Hi everyone, welcome. Today we're diving into an alternative explanation for a well-known cosmic puzzle. Why stars in galaxies don't slow down the way we expect them to. This presentation explores an idea that challenges the dark matter narrative by looking at the atomic rest mass itself. So here's the issue. When we look at how stars rotate around galaxies, especially farther out from the centre, they don't slow down like Newtonian physics says they should. Instead, they keep whirling around at more or less the same speed. That's weird, and it's led scientists to propose dark matter, invisible stuff that holds everything together with gravity. But what if there's another explanation? What if the rest mass of atoms, basically how much mass an atom has at rest, isn't the same everywhere? What if it gradually increases the farther out you go from the galactic centre? That would make outer stars heavier in terms of inertia, which could explain why they move faster than expected, even without invoking dark matter. Let's talk about redshift for a second. Usually we assume that the redshift near a galactic core is due to gravity. Light escaping a strong gravitational field loses energy, so it gets redshifted. But what if the atoms themselves have less rest mass near the centre? That would mean they naturally emit lower energy photons, making things look redshifted, even without gravity. This could mess with how we interpret star velocities based on redshift, and again, maybe we don't need dark matter to explain it. Now, this isn't an open and shut case. There are a few hurdles. We need a consistent pattern of mass variation across different galaxies. Atomic transitions are extremely well studied. Any changes in mass need to match what we've already observed. And most importantly, we can't break everything else in physics, like how galaxies form or how light bends around massive objects. Still, it's worth exploring. So, how do we test this idea? We build a model. We start with a typical galaxy mass layout, bulge, disk, halo. Plug in a rule that says rest mass increases with distance from the centre. Then calculate how that changes what we think we're seeing in terms of star speeds. When we run that basic model, something interesting happens. We get a flatter rotation curve, kind of like what we actually observe. This happens because the redshift-based velocity measurements get scaled by the higher atomic masses at the edges, so this basic version seems to support the idea. But we didn't stop there. We added in gravitational redshift and a more realistic galactic mass profile, and voila, the result still matches up. The outer velocities stay almost flat. The gravitational redshift tweaks the curve slightly, and the increase in atomic mass keeps it from dropping like Newton would predict. Together they might explain the whole thing. Again, no dark matter needed. Let's take a step further. Holt and Arp argued that some objects like quasars get ejected from galaxies at speeds near the speed of light. If that's true, and the particles in those jets had normal rest mass, they need infinite energy to escape the supposed black hole at the centre of the galaxy. And also, the immense amount of energy means that they would just break apart. But if the matter in those jets had very low rest mass, it suddenly makes sense. That points to galactic cores being made of low rest mass material, as Holt and Arp predicted, lining up with this whole alternative theory. So that's the big idea. Maybe we don't need dark matter to explain flat galactic rotation curves. Maybe all we need is a shift in how we understand atomic mass in different parts of a galaxy. It's still a developing theory, but it's an intriguing one and definitely worth further explanation. Thank you for listening.